So in section 2.2, the big focus is matrices, which is something we'll deal with next week. But what we'll approach first is the algebraic method for solving systems of three equations with three unknowns. The biggest thing here to recognize is that graphing and substitution, while possible, become more difficult, maybe to the point they're not as useful. So really, elimination is the best method. But even elimination is quite complicated, and so that's why we'll study matrices later on, and also because later on we'll be dealing with really strange situations such as 2 equations with 5 unknowns, 10 equations with 2 unknowns, all kinds of things that will be more difficult to apply elimination to directly. So when we look at this algebraically, the goal will be to eliminate one variable in 2 of the equations and then the same variable in 2 other equations. The reason you want to do that is because then you'll end up with one system of 2 equations and 2 unknowns. So in other words, we're doing the classic math thing. We're reducing a problem to something we've already done before. Then we'll have that system to solve, and once we solve that system of equations, we'll have an answer for 2 of the variables. Once we know 2 of the variables, we can go back to one of the other equations and get the remaining variable. So let's go through and actually do this with this given system. You know, as I've been talking, I've been eyeing this system and I've been looking, thinking, what will I eliminate? Well, I'm going to name these so I can keep track, and what's been catching my eye is this part right here. I'm thinking that's basically no work to eliminate that z, so that's what I'm going to do. So my first step, and this isn't the only first step that you could do, but this is my first step, is to eliminate z in 2 and 3. Okay, and the way I can do that is just by adding these up, right? So this is 2x plus 3y minus z equals minus 2, and this is minus 3x plus 4y plus z equals minus 8. When I add these up, I get negative x plus 7y equals minus 10. Okay, so notice, one equation with 2 unknowns. I need another one to be able to do anything. So what I need to do now is pick 2 other equations and use those and eliminate z. Okay, it really doesn't matter which 2 I pick. I'm looking, 1 and 2 are next to each other. It'll be easier to deal with, so I'm going to use 1 and 2. Again, this is a choice you can make. Some choices are nice and some aren't. Kind of depends on how bad the arithmetic gets. It's hard to tell ahead of time. But what is nice is because this has a coefficient of negative 1, all I got to do is multiply this equation right here by 2, and I'll end up with a negative 2 and a positive 2, so I'll eliminate what I need to eliminate. So my first equation is x plus y plus 2z equals 12. Okay, my next equation is 4x, and then 2 times 3 is 6, so plus 6y minus 2z equals, and then it'll be minus 4. Okay, so I add these up. I get 5x, I get plus 7y, and these cancel, and I end up with 8. Okay, so now I have a system of 2 equations and 2 unknowns, the answers from these 2. So my step 3 will be to solve this system. So I want to solve the system minus x plus 7y equals minus 10, and 5x plus 7y equals 8. All right, so looking at this, we got the 7, we got the 7. Wouldn't it be easy just to multiply by negative 1? And in fact, that's kind of straightforward. This would become positive, this would become negative, and this would become positive. So if I was to add these up now, what would I end up with? Well, I end up with, again, this is now positive, 6x, negative 7y plus 7y, that's gone, and equals 18. So all I did was multiply this equation by negative 1, this one right here, by negative 1. Okay, if 6x equals 18, then x equals 3. Very nice. Now I can use one of these 2 equations to figure out what y should be. I can use the first equation, and I get, remember, if I multiplied by negative 1, the original equation was right here. So I get negative 3 plus 7y equals negative 10. In other words, 7y equals, this will be positive, so this is going to be a negative 7. Y equals negative 1. Okay, so notice I got now 2 of the variables. This isn't how you want to leave your final answer, of course, but I'm just marking them so I can see them. Now what do? Well, I can use any of my original equations to figure out the value of z. You know, I want to pick an easy one. Look at 3. The z's by itself, it'll be really easy. Okay, so that equation tells me minus 3 times x. Okay, that's 3. Plus 4 times y. Well, that's negative 1. Plus z, we don't know that, equals negative 8. So in other words, I got negative 9 minus 4 plus z equals negative 8. This is actually minus 13 plus z equals negative 8. So in other words, z equals, if I bring this over, I get positive 13, so z equals 5. All right, so finally, after all that mess, my answer is x goes first, so this would be 3, then the y, negative 1, and then the z, 5. So this is my solution. And so looking at this, you can see this was not necessarily hard, but it was complicated, right? There were many steps to keep track of, and it was very easy for us to make a mistake. At any of these stages, we could have accidentally added wrong because we were going fast or something. So this shows you that this is probably about as far as we want to go with elimination, but it's certainly doable, and it's certainly something that we could use for solving this type of system. So when you approach these, again, pay attention to things that will make your calculations easier, like we saw with the negative z and the plus z, and with the 7y and the other 7y. And remember to just go step by step and be careful with your arithmetic.